Okay, in this next section, we're going to be doing quadratic equations and vertex form. We've already learned the standard form of the quadratic equation. That is the ax squared plus bx plus c. And today we are going to learn what is called vertex form. I'm going to write that up here just above the equation they've given us. It is a times x minus h squared plus k. And I'm going to put some arrows on this k, and that's going to mean something here in just a minute. So Mrs. Collins asked her class to graph the function g of x equals a times x minus 3 squared plus 1. Using your knowledge of transformations, describe how each part of g of x, highlighted below, will affect the parent function f of x equals x squared. Then complete A through C. So f of x equals x squared. It is a quadratic function, and it is going to be a parabola, and you will see they have that parent function plotted over here. I want to point out that your vertex here is 0, 0. This is the standard parent function parabola. Always goes through 0, 0. Okay, so let's look at the difference between our parent function and our g of x function. I notice they've put in a 2, a 3, and a 1. So let's talk about what each of these do. So the 2 is the a value. The a value is 2. And that, as we have learned, is going to tell us that it opens up because it is positive. But it is going to be a vertical stretch by a scale factor of 2. So what's going to happen here is you're going to pin down the vertex, and you're going to grab the arrows, and you're going to vertically pull up. And when you do that, it is going to get more narrow. So we're going to say it's going to be narrower. Okay, it's going to get thinner, skinnier. Technically, the term you use is more narrow. Okay, next we're going to look at this 3. I want to point out that the equation says x minus. So the minus is supposed to be there, so all we did was substitute a 3 for the h. So here we're going to say that h equals 3, and h actually represents a horizontal shift, so you either move right or left, and since the h is positive, that is going to cause the parabola to shift right 3 units. So you would take this vertex here and you'd move to the right 1, 2, 3. 3 units to the right. All right, then the last value, they put in a 1. This is the k. So we would say k equals 1. And this is going to shift the vertex up 1. So just a second ago, we shifted it to the right, 1, 2, 3. Now we must shift it up 1. And we have a new vertex here. This vertex is going to be 3, 1. And remember, we said that the parabola is still opening up, but it's going to be more narrow than this one. So I'm just going to sketch a thinner, more narrow parabola right there. So here's just a good sketch of the graph. So notice the vertex 3, 1. That is what your h and your k value were. Hence the reason it's called vertex form. So let's look at A, B, and C. A, sketch it. We already did that. B, find the vertex, g of x. Okay, our new vertex is 3, 1. And then where do the values of the vertex appear in the equation above? Oh, we just talked about that. Okay, so we just saw that the h value is 3 and the k value is 1. So hk is the vertex. HK is the vertex. All right, so let's take that information and complete this table at the bottom. It says for the vertex form, here it is, a times x minus h squared plus k. HK is the vertex. Okay, the value of A, there's the A, determines which direction the parabola opens, meaning does it open up or down, and it also determines how wide it is. So we're going to look at that A value, and it's going to tell you if it's up or down and how wide it is. And then we're going to look at the H and the K value, right? And it's going to tell us what the vertex is. All right, so over here, we're going to begin by identifying that H is 5, K is 2. So we are going to write that vertex of 5, 2. Okay, now the A value in here, it's in front and nothing's there, so it's a 1. That means the positive 1 is going to have a parabola that opens up. So the question is asking us, do we have a minimum or a maximum? So this one is a minimum, and you'll remember from our last lesson that the minimum is based on the y value, so it has a minimum value of y equals 2. Okay, let's do a couple more of those. We're going to find the vertex over here. Oh, looky here. This is supposed to be a minus h. So the only way to get a minus to turn into a positive is you have to have a double negative. So they actually substituted a -6. That is probably the hardest thing to remember today. And then my k value is a -4. And let's look at that A. The A is positive, so the parabola is going to open up, which makes the vertex a minimum again. And the minimum value is your y, so your minimum y value here is -4. Now, I always get the question, Mrs. Keller, -6 is smaller than -4, so why are you calling -4 the minimum? Well, remember, the minimum is how far down it went, and the y value is what determines how far down the parabola dropped. Okay, so for the third one, let's go locate our h and k. So our h is 10, and there's nothing out here, so when there's nothing there, it's a 0. And then this a value here is negative, so that tells us the parabola opens down. So that vertex is now going to be a maximum. What is the maximum value? Well, I know 0 is not a very big number, but it is the top of the parabola. The y value is 0. Okay, at the bottom, we're going to have quite a bit of work here. We're going to apply some of our multiplication skills from the last unit to change it from vertex form into standard form. So that's what the directions say. Functions written in vertex form can be converted to standard form by simplifying. In 1 through 3, identify the vertex of the function, then write the function in standard form. Okay, so first thing is, let's go identify this vertex. My h value is 4, and my k value is 5. Okay, now to get it into standard form, that is ax squared plus bx plus c, standard form, I'm actually going to have to do all the multiplying and combining like terms. So I'm going to write this out as x minus 4 times x minus 4 plus 5. And last unit, we learned to multiply this using the box method. So I'm going to do that fairly quickly out here. I have x minus 4 up top, and then x minus 4 down the left side. X times x is going to be x squared. X times negative 4 is negative 4x. Negative 4x times x is negative 4x. And then the last box, negative 4 times negative 4 is a positive 16. So I'm going to have x squared. We're going to combine the diagonals here. Remember, we add these in the middle. That's why that looks like a plus sign in the middle. Negative 4 plus negative 4 is a negative 8x. And then our positive 16. Now, we've only done the multiplication here, so we still have to bring down that plus 5. And then we're going to combine our constants to be x squared minus 8x plus 21. That is standard form. Ax squared, there's our bx, and there's our c. So standard form, f of x equals x squared minus 8x plus 21. So with all this information, I know my a value is a positive 1. It's going to open up. It has an x squared. It's going to be a parabola. The vertex is 4, 5, and the constant, it tells us where it's going to touch the y-axis. So this one will touch the y-axis at 21. Okay, number 2. G of x equals 3 times x plus 2 squared. So this actually is going to turn into 3 times x plus 2 times x plus 2. Now, I'm not going to do the box method every time because y'all already know how to do this. So I'm going to go ahead and tell you what it comes out to be. It's going to be x squared plus 4x plus 4. And then the very last step is to distribute the 3. I need to do that 3 times. So 3 times x squared is 3x squared. 3 times 4x is a positive 12x. And 3 times 4 is a positive 12. So here we go. Here is my ax squared plus bx plus c. All right, so vertex. All right, let's go back to the original equation. Here's my vertex, my h value. Let me write that in here. Okay, that's supposed to be a minus sign. So the only way to get the x minus to change to positive is a double negative. So my h value is a negative 2. And then my k value, there's nothing there. So k equals my 0. So the vertex is negative 2, 0. I probably should have marked that for y'all up here also, that h is 4. And k equals 5. And your 4, 5 is what gives you your vertex down there. All right, my g of x standard form here is 3x squared plus 12x plus 12. So parabola, because it's x squared, positive 3 opens up. The 3 is going to give it a good stretch, which will make it narrow. The vertex is negative 2, 0, and it's going to touch the y-axis at a positive 12. All right, h of x. Let's go ahead and start with the vertex again. So my h value right here is 1. There we go. The minus is supposed to be there. And then the k value is -8. So we're going to use the h and k to write the vertex. Ooh, there's a negative in front right here. That means this parabola is going to open down. All right, so let's go ahead and do this multiplication. It's negative times x minus 1 times x minus 1, and then a -8. So the first thing I'm going to do is the binomials need to be multiplied. X minus 1 times x minus 1. So my negative is sitting in front, and I get x squared minus 2x plus 1. And then the -8 is outside parentheses. The next thing I need to do is distribute the negative. So remember, when you distribute the negative, the shortcut is everything just changes signs. So my positive x squared becomes a negative x squared. Negative 2x becomes a positive 2x. Positive 1 becomes a negative 1. And then I have my -8. I've dropped my parentheses because the parentheses are for multiplication. So once you distribute and your multiplication is done, you can now drop the parentheses. Okay, and the last thing is I just need to combine these constants here. So negative x squared plus 2x, negative 1 minus 8 is a -9, a negative 9. So my standard form, negative x squared plus 2x minus 9. X squared makes it a parabola. The negative, it opens down. The vertex is 1, -8, and it's going to touch the y-axis at -9. Okay, now let's look at this. Last question down here. Describe how you could prove that the vertex form and standard form of each function above are equivalent functions. So what they're saying is, like, look at number 1. How can you prove that f of x equals x minus 4 squared plus 5 is equivalent to the f of x equals x squared minus 8x plus 21? How can we prove that they are the same? Well, would their graphs look the same? Sure would. So graph both functions to see if they are identical. They should overlap each other perfectly. If they don't, then you've done something wrong to change it from vertex form to standard form. Okay, let's go ahead and flip it over and do the back side. Okay, here to the left it says vertex form can be used to write quadratic equations. When given the, well, if it's called vertex form, you have to know the vertex and another point on the graph. So if you know the vertex and one point on the parabola, then you can actually come up with the equation in vertex form. So here are the steps we're going to go through while doing problems 4, 5, 6. Okay, so question number 4. Function g has a vertex at 1. That's going to be my h value. And 1. So remember, vertex is always hk. And it passes through the point. Okay, here we go. Passes through the point. 0 is going to be an x value. And it also passes through the point 2, which is the y value. So I have a h, a k, an x, and a y value. So write an equation for g of x in vertex form. All right, so let's remember, vertex form is a times x minus h squared plus k. So g of x is just y. So I'm going to put a 2 right here. Equals, I do not know my a value. That is actually the only variable I do not know. I need to find it in order to write this equation. My x value here is a 0 minus the h value is a 1 and the k value is a positive 1. So we're going to PEMDAS this. We're going to solve it for a so that we can actually write the equation as we need. So first of all, PEMDAS is inside parentheses. So 0 minus 1 is going to be a negative 1. Okay, after inside parentheses is exponents. So negative 1 times negative 1 is a positive 1. We are now going to subtract 1 on both sides, and we have just learned that the a value is 1. So we're going to write our equation, and we need to substitute numbers for a, h, and k. So our a value is 1, so I'm going to put a 1 in the front. Now remember, you don't have to have that 1, and on a standardized test, the 1 will not be there. Next is x minus h. My h value is also 1. And then at the end, the plus k, and my k value is a 1. Now this does not normally happen. All of your values are not a positive 1. They just gave you some easy numbers to work with for your first example. Okay, let's do that again. Number 5. Function h has a vertex at negative 2, 8. So my h value is going to be negative 2, and my k value is going to be 8. All right? And passes through the point negative 4, 0. So that's just a random point on the graph. So we're going to say x equals negative 4 and y equals 0. Now we're going to take these 4 points and substitute into vertex form. I think they said we're using h this time. Not that it matters. It's really just y equals. I'm going to write this vertex form over and over and over so we can get it memorized. Okay, h of x is just y, so I'm going to put a 0 in here. Equals, I do not know my a value. All right, do we have a number for x? Yeah, the value for x is negative 4. And then minus. And our value for h, is a negative 2. So what happens if we substitute a negative 2? The double negative is going to turn positive. And then our k value is a positive 8. All right, so we're going to simplify the right side, and after we get the whole right side simplified, we're going to solve for a. So first thing we do is inside parentheses. So inside these parentheses, negative 4 plus 2 is a negative 2. Next is going to be exponents. Negative 2 times negative 2 is 4. So I have 4a plus 8. Now this is simplified. I'm going to begin to move across the equal sign. So I'm going to subtract 8 on both sides. And I'm going to get 4a equals negative 8. And then the last step will be to divide both sides by 4. And when I do that, I get a equals negative 2. Okay, I'm going to turn this paper to kind of get me some room to write this equation. It takes quite a bit of work. So h of x equals, my a value is negative 2. That tells me my parabola is going to open down and be a little narrow. X minus the h value over here is a negative 2. So when you substitute a negative, the double negative turns to a positive. And then your k value to substitute is a positive 8. So there is the function. Okay, now how could you check that? How could you check that this equation has a vertex of -2, 8 and also goes to the point -4, 0? Can we graph it? Graph it. Go look. Is this the vertex? Is this point on the parabola? If they are both not on the parabola, you've done your algebra wrong. Try something else. Okay, question number 6. Function m of x is represented on the graph to the right. Write an equation for m of x in vertex form. Okay, so vertex form means let's go find our h and k. So here we go. Here's the vertex. Starting at the origin, I went right 3, and it looks like I went down to -3. So 3, -3. That means that my h is going to be a positive 3, and my k is going to be a -3. Now, since I have a graph, I'm going to show you a little shortcut on how to find your a value. If you can identify your first reference point, that is the first whole number coordinate, you will see that it's right here. It goes up 1, right 1. So up 1, right 1, 1 over 1. It's like a rise and run, but the rise and run changes as you go up. But if you can find the first reference point, your a value is rise 1, run 1, which is 1. And then just double check if it's positive or negative. The parabola is opening up, so your a value needs to be positive. So we're going to take our a, h, and k, and we are going to substitute those values into vertex form. So we're going to put our a value right there. We're going to put our h value inside the parentheses, and then our k value on the outside. So here we go. M of x equals 1. Do I have to write the 1? I do not. X minus the h value is 3. Close your parentheses. Don't forget your squared. That's what makes it quadratic. And then my k value is a -3. So I'm going to put a -3 right there. B says, write the equation for mx in standard form. Okay, so standard form is going to be the ax squared plus bx plus c. Okay, so I need to take this and multiply it out. So m of x equals x minus 3 times x minus 3, and then put a -3 on the outside of the parentheses. Okay, you are going to want to go multiply this on your own using the multiplication box or whatever method you know. And when you multiply that, you're going to get x squared minus 6x plus 9. Some of y'all maybe, because I've done 4 of them now, I've started picking up on the pattern. And then we must bring down the -3. And all we have left to do is combine our constants. So this turns into m of x equals x squared minus 6x plus 6. All right, so let's compare this to the graph. The a value is one that opens up. Yes, the parabola opens up. The vertex is 3, -3. Yes, the vertex is 3, -3. This constant of 6 says it touches the y-axis at 6. Does it cross the y-axis at 6? Yes, it does. I could graph both the vertex form and the standard form, and they should both give me this parabola exactly the same. Okay, number 7. Mr. Turner graphs the function g of x and h of x on the same coordinate grid. The function g of x has a vertex of 2, 10 and passes through the point 0, 2. Function h of x is negative times x minus 4 squared plus 8. Which function has a greater maximum? Okay, so I'm going to kind of color code this a little bit. We are going to put that g of x has a vertex of 2, 10 and passes through 0, 2. So let's kind of just look at this. We're going to sketch. So I'm going to say the vertex is at 2, 10. That's going to be way up here. And it goes through 0, 2. Okay, that's all I know. Did it say whether it opens up or down? Well, if the vertex is right here, doesn't it have to open down, right? So this is a max at y equals 10. All right, now let's do the second one, h of x, and this is my vertex for 8. So for 8, and is this parabola opening up or down? I see it has a negative in front, so it's opening down as well. So that vertex is a maximum, and the maximum value is y equals 8. So the question says, which function has a greater maximum? Okay, which function has the greater maximum? The first one, explain your reason. So g of x, because the y value is bigger. The y value of 10 is bigger, which makes it higher than the y value of 8. Okay, last question. Consider the function f of x equals negative 2. That means my a value is negative 2 times x plus 7 squared minus 9. Okay, that means my h value, careful here, that's supposed to be a minus. The only way to make it a positive is a double negative. So my h value is negative 7. My k value is a negative 9. So that means my vertex is negative 7, negative 9. Okay, well, what does the a value tell you? Well, the a value tells you that it opens down and it's going to be more narrow. Okay, it's going to be more narrow than the parent function. Mark each statement about the function as true or false. If false, rewrite the statement correctly. Okay, the function's graph will have a vertex at 7. What's wrong with this? That's wrong. That should be a negative 7, negative 9. So that one is false. B, the function's graph will have a range of y less than or equal to 9. Okay, well, let's go kind of consider that. So we said we have a parabola that opens down and it's pretty narrow, and we have the vertex at negative 7, negative 9, and the range, as we learned, is based on that y value. So I know it starts at negative 9 and it's going down, which means it's getting less or equal to. So does that match y less than or equal to? Yes, it does. Okay, the function is equivalent to f of x equals negative 2x squared minus 14x minus 9. Okay, so to do this, I can either multiply this out, or I can go graph both in Desmos and see if they look the same. So let's I'm going to move over my video, and we're going to graph the two, and we're going to see. It's going to take me a second to get this hooked up so I can see if it looks okay. Let me change this a little bit. Give me a second. Okay, let's see, and hopefully this works. Find my mouse. There it is. Okay, so we're going to come over here and we're going to graph the first one as f of x, oops, close my parentheses here, equals -2 times x plus 7 squared minus 9. I've got to get rid of this little 0 here. There we go. Okay. Not seeing anything yet, so let's see if we can hit a, should cross that negative, oh, here we go, should cross, okay, here we go, there we go, there it is, okay, and then I'm going to graph the second one, which is g of x equals -2x squared minus 14x minus 9. Okay, are they the same? No, absolutely not. Those graphs are not the same. So whoever multiplied that out did not do a good job. They did not multiply it out correctly. Okay, so in order to prove it wrong, we are going to need to multiply. Let me pick this up and get it lined up again. We are going to need to multiply the f of x out. So here we go. It's going to be f of x equals -2. My x plus 7 squared is going to be x squared plus 14x plus 49 minus 9. Distribute the -2. You get -2x squared minus 28x minus 98, and then minus 9. Oh, you can see we're way off here. And so this turns into, somebody probably forgot to square the x plus 7. And so I have -2x squared minus 28x, and then this 98 minus 9 is going to become a -107. So here is what the equation should have multiplied out to be. Okay, good luck.